this video, we'll be studying about electric, where we'll be seeing the heating effect of electric current. Okay. Suppose, let's say this is your circuit. Okay. Now, this EMF is, let's say, E. Resistance R. Suppose these are 2 points. Okay. A and B. Current is being supplied. Let's say potential difference between A and B. Now, let's say current I flows through the circuit for time t. Okay. Then, what will be the charge flown from A to B in that time interval? Okay. It will be Q is equals to I into T. Okay. Right. And work done by the battery, that is electrical energy supplied by the battery in charging, in carrying a charge Q from A to B, that will be W is equals to that. If this is point A, this is point B, if, their potential difference is V and charge is Q, and the work done will be Q into V. Okay. And if R is the resistance of electrical device, to your electrical device, okay, you know that V will be I into R. Okay. So from here you can write W is equals to Q into V is equals to V into I into T. You can write Q is equals to I into T. And you can also write it as, you can write, put the value of V here, it will be I square R into, or V square by R. Therefore, electrical energy is what? Nothing but W is equals to I into T. V is equals to V square T by R equals to I square RT. Okay. And one more thing, that if you want to convert joule into calories, see, these things will come in joule generally. Okay. And if you want to convert it into calorie, 1 calorie is equals to 4.2. Okay. Now, electric power, it is basically the rate at which electrical energy is transformed into other form of energy by electrical device. ठीक है, ये क्या हो जाएगा आपका इलेक्ट्रिक पावर. ओके, इट मीन वर्क डन पर यूनिट टाइम, जो कि सप्लाई हो रही है एनर्जी. ठीक. अब इसको क्या लिख सकते हो आप? E is equals to V into I. Okay, is equals to V square on R. You just need to divide all these equations, right? Equals to I square. Okay, ये आपका क्या हो जाएगा? इलेक्ट्रिक पावर. ओके. अगला टर्म आता है किलोवाट आवर. ये काफी इंपॉर्टेंट है. बोलते हैं नंबर ऑफ यूनिट. 1 kilowatt hour or 1 unit is the quantity of electric energy which is dissipated in 1 hour. ठीक है, ये क्या हो जाएगा? या इसको कहते हैं 1 यूनिट. ठीक है, ये वो अमाउंट ऑफ एनर्जी होती है जो कि किसी भी सर्किट में 1 आवर के लिए जो इलेक्ट्रिकल एनर्जी डिसिपिएट हो रही है. ठीक है, वेयर योर इलेक्ट्रिक पावर इन द सर्किट इज 1 किलोवाट. ठीक है, ये वो एनर्जी होती है. ठीक है, तो यू कैन राइट इट एज it is the quantity of electric energy which is dissipated in 1 hour in a circuit where your electrical power that is being supplied in the circuit is 1 kilowatt. Okay, so 1 kilowatt per unit, you can write it as 1000 watt. Okay, into 300 3600 seconds. So this can be written as, what can be written as joule per second. we are converting what kilowatt hour into our unit, that is joule, okay, in which it is easier to do problems, okay. This will get cancelled down and this will be 3.6 10 power 6 joule. This is your 1 kilowatt hour, okay? So this was your electric energy, electric power and kilowatt hour. Now we'll be studying power consumption in series combination and parallel combination. First is power consumption in series combination, right? Now if you see, let's say a bulb is there whose power is P1 and operating potential is V1, okay. Let's say both are connected, and another bulb which is operating power is P2, okay. Okay. Suppose this is P1, this is V. Let's say your resistance R1, your resistance R2. Resistance of P1. Oh, sorry, bulb 1. Okay. Resistance of bulb 2 is R2. Okay. Now, from here you can write P is equals to, you know that it will be V square by R. Okay. From here you can write R equal to V square by P. So you can find R1. R1 will be V square by P1 and R2 will be V square by P2. Right. And you modify the circuit, it will be somewhat like this. Okay. Your LP, this is your R1 plus R2. Okay. Since they both are in series, so your P net will be your potential V square upon net resistance, that is R1 plus R2. Now you can put the values of R1 and R2. P net equals to V square upon, you can write R1 as V square by P1, sorry, V square by P1 plus you can write R2 as V square by P2. Now if you take V square common and take the LCM, this P1 P2, you will get P net is equals to P1 P2 upon P1 plus, this will be your net power. Okay. Now you know that in series combination current is same all throughout. Current will be same. That means P is equals to I square R. That means P is directly proportional to R. This implies what? Brightness will be directly proportional to power consumed by the bulb, which is directly proportional to R. Okay. Brightness is directly proportional to power consumed. This will be directly proportional to this R, and this will be directly proportional to 1 upon P, the value which is given. Okay. This means bulb of lesser watt will shine more. Right. This will be your in series combination. Okay. Now power consumption is in parallel combination. In parallel combination it will be same. Okay. Here one difference will be there, that your in series your current was same, and in this your parallel will be same. Okay. Oh sorry, voltage will be, right. Your bulb 1, your bulb 2. Okay. ठीक. अब ये P1 है, V है, ये P2 है, V है. ठीक है. अब इसका रेजिस्टेंस R1 मान लो, इसका रेजिस्टेंस क्या मान लो, R2 मान लो. ठीक है. अब इस केस में पी नेट क्या निकला था, P1 P2 बाई P1 प्लस P2। इस केस में क्या निकल जाएगा, पी नेट विल बी P1 प्लस P2, राइट। तो अब ये हो जाएगा नेट पावर, ठीक है। अब मालूम है कि पैरेलल कॉम्बिनेशन में क्या होता है, आपका वोल्टेज क्या होता है, सेम होता है, ठीक। तो जब वोल्टेज सेम होगा तो पी क्या हो जाएगा, P² बाई R। अब ये सेम है, इसका मतलब P इनवर्सली प्रोपोर्शनल टू R। दिस विल implies what, the bulb of greater watt will shine more, bulb of greater watt will shine more, right. This was your reason, parallel combination, electrical energy, electric